Hello, Math 130 students. We will pick up on page 21, section 1.5, which is compound inequalities. So two or more sets can be combined by the operations of union and intersections. So here that Venn diagram kind of helps us represent the intersection. The intersection is everything that they have in common, so it has to be an A and B. Versus the union is just everything. It's an A or B. So thinking about these definitions, let's move on to the next example. It says solve and write solution in interval notation. So we have and, right? So we have this inequality and that inequality. So first of all, this word and, well, what is it telling me? Well, here's and, it's going to be our intersection. So it's going to be everything that they have in common. So the first thing I want to do is I want to go ahead and just figure out what these solutions are going to be. So for part A, let's say I have my x over 4 greater than or equal to a negative 1. So then to get the x by itself, I'm going to multiply by 4 over 1. So it's like multiplying by 4 on both sides. So x is greater than or equal to a negative 4. Now for part B, let's look at that negative 4x minus 4 less than or equal to a negative 3. So I'm going to add 4 to both sides. So that negative 4x is less than or equal to a positive 1. And then from here, I'm going to divide by a negative 4. And you have to be careful. Whenever you divide by a negative 4, you're actually going to change the way the inequality faces. And I kind of explained that a little bit in section 1.3. So now I'm going to say that x is greater than a negative 1/4. Okay? So if I were to graph this on the number line, let's just say 0 is over here. So a negative 1/4 is here, a negative 1 is here, and negative 4 is here. So what this is saying is for x is greater than negative 4, so at negative 4, it's a filled in circle and it's greater, so I'm going towards my bigger numbers, which is going to be positive. Now over here, x is greater than or equal to a negative 1/4, then again I have a closed, let's change the color here. So the color I wanted was really green, so at negative 1/4 I have my green dot, it's closed and it's filled in, and x is greater than or equal to a negative 1/4. So I'm going in that direction. So the intersection, as you can see from the Venn diagram, it's everything that they have in common. So let's just think about negative 1. If I'm looking at negative 1, does the green equation include negative 1? No, it doesn't. Does it include negative 3? No, it doesn't. When do they both see the blue and the green overlap? Well, those two overlap in this section starting at that negative 1/4. So the intersection, that and, is going to be written as follows. I'm going to say that my solution is going to start at a negative 1/4. It's a closed filled in circle and it goes off to a positive infinity. So I have my minimum value and my maximum value. And so that's going to be my final answer there, okay? And it's all because of that one word, which was and. So I'm just thinking about the intersection. Where do they both overlap? What do they have in common? So let's think about this again over here. So here I have the word and. So whenever I have that word and, I'm thinking about the intersection. So I'm going to look at where things are overlapping. What do they have in common? So again, let's go ahead and take the first inequality, which is 5x plus 2 greater than or equal to a negative 8. So I'm going to subtract 2 to both sides. So now I have 5x is greater than or equal to a negative 10. Now I'm going to divide by a positive 5, so x is greater than or equal to a negative 2. Now for my part B equation, that's negative 4x is greater than a negative 24. I'm going to be dividing by a negative 4. That means the inequality is going to change direction because I'm dividing by a negative. So I have now my x value. Now it switches direction. And if I have 24 divided by 4, that should give me 6. So now, and I'm a very visual person, so I'm going to go ahead and just draw it out. So I have negative 2. Now I always like to put 0 on these things because, why not? And I have a positive 6. So at negative 2, it says that x is greater than or equal to negative 2. So that means inequality is going this way. For x is less than 6, I have an open circle, and it's going this way. So where does the blue and the green overlap? They overlap here in this section. So my answer going from minimum to smallest, I have at negative 2 bracket, positive 6 parentheses. And you might be thinking, well, why is it a parentheses at the 6? Because it's an open circle. Well, why was it an open circle? Because there is no line underneath inequality. So that is going to be my final answer. Bracket negative 2, comma, 6 parentheses. So now for number 3, it's a compound inequality. So I just have to get the x isolated. So what I'm going to do is I'm going to add 5 to all 3 parts so I can start isolating the x variable. So negative 6 plus 5 is negative 1. And I have 5 plus 1, which is a positive 6. From here, I'm going to have to divide by 2. So I divide each side by 2. So now I have a negative 1/2 less than or equal to x less than 3. So if I were to graph this thing, I have a negative 1/2, a positive 3, and a 0 if you want that for reference. So what's happening at that negative 1/2, I have a closed filled in circle. And at positive 3, it's an open circle. And the solution set is, because it's compound, everything is being squished in between. So everything between negative 1/2 and 3. So my answer is going to go from negative 1/2 bracket to a positive 3 parentheses. So that's going to be my final answer, that interval notation that goes from smallest value to biggest number. And we're going to do the exact same process for number 4. So to get the x isolated, I'm going to subtract 6 from all 3 sides. So then 9 minus 6 is going to give you a positive 3, less than 3x, less than or equal to 15 minus 6, which is a positive 9. From here, I have to divide by 3 to get the x by itself. So I'm going to have 1, and then x, and a positive 3. So if you want that visual, I have 1 and I have 3. So at 1, it's an open circle. At 3, it's a closed filled-in circle, and everything is being squished in between. So I go from 1 to 3, and it's a parentheses and a bracket. Now we're changing it up a little bit. Now I'm looking at the word or. So if I'm looking at the word or, I'm thinking about the union. And the union is basically everything goes. Okay. So the first thing I want to do is isolate that v variable. So 4v plus 5 less than 29. So I'm going to subtract 5 from both sides. So that 4v is less than 29 minus 5, which is 24. And then I will divide by 4 on each side so that v is less than 6. Now for my part B, which is at 3v minus 2 greater than or equal to 1. So I'm going to add 2 to both sides. So that 3v is greater than or equal to a positive 3. Now to get the v isolated, I have to divide. So that v is greater than or equal to a positive 1. So I have 1 and I have 6. So x is greater than or equal to a positive 1. That means it's a closed filled-in circle going in this direction. If v is less than 6, then that means it's an open circle and it's going this way. So notice how it's union, right? So it's everything. So you can think of it as, well, your blue equation is going towards negative infinity, and your green equation is going towards my positive infinity, right? Beyond 6 is 7, 8, 9, 10, 100, 1,000, a million, a billion, eventually infinity. Same thing with 1, right? You're going to go to 1, 0, negative 1, negative 2, negative 100, negative 1,000, you know, all the way up to negative infinity. So both of these blue and green lines, they're stretching infinitely at both directions of this number line. So what that tells us is that it's going to be all numbers. So I'm going to go from negative infinity to a positive infinity. And infinity will always have parentheses. So that ends up becoming my final answer in interval notation. So let's see what happens with number 6. So I'm going to look at my first equation, 2y minus 1 greater than or equal to a positive 3. So I'm going to add 1 to both sides, so that 2y is greater than or equal to 4. To get the y by itself, divide by 2. So I get y is greater than or equal to a positive 2. Now I have y is less than negative 2. There's nothing I need to do to simplify that, so that's perfect. But remember that or is the union, which means everything. So I can think of it as I have a positive 2 over here, and I have a negative 2 over here. And if you need it, zeros right in between them, right? So if y is greater than or equal to a positive 2, that means it's a closed filled-in circle going in this direction. If y is less than 2, that means it's an open circle, and it's going towards my negative infinity. So remember, negative infinity always lives here, and positive infinity lives over here. So yes, this represents everything, but let's think about this. If this is positive 1 and negative 1, are those included? No. So there is a gap in between your numbers. So the way you're going to say this is this goes from negative infinity to negative 2, union, and it picks up at positive 2 bracket, and it goes off to positive infinity, which is going to be my parentheses. So that ends up becoming your final answer. Okay, so now this next example. It says Juan is creating a rectangular garden in his backyard. The length of the garden is 20 feet. The perimeter of the garden must be at least 70 feet and no more than 86 feet. Use a compound inequality to find the range of values for the width W of the garden. So what we want to do is we definitely want to build this compound inequality. So remember, whenever you have this compound inequality, you have your minimum amount less than or equal to something, and then you have your maximum value, right? So you have your minimum value and you have your maximum value on each side. And for this particular equation, it's specifically asking you to find the perimeter. So perimeter. So let's think about this. If our minimum value, well, it specifically says that the minimum value here must be at least 70 feet. So that's going to be your minimum value. So I'm going to have 70 as my minimum. Now it's going to talk about my maximum. It says no more no more than 86 feet. So the maximum value is going to be 86 feet. Well, if I use perimeter, well, I know that the general equation for perimeter is really my perimeter is equal to 2L plus my 2W. So here I'm going to have 2L plus my 2W since I'm talking about perimeter. But there's a particular value that they give us. The value that they're going to give us here is that the length of the garden is 20. So that's my L value right there. So I'm going to plug that in. So 70 less than or equal to 2, and the L value is 20. And I'm trying to find my width. So now I have 40 plus 2W less than or equal to 86. So I'm going to subtract 40 from all three pieces. So that 70 minus 40 is 30. I have my 2W, and 86 divided by, oops, and that's not divided, it's subtract. 86 minus 40 is 46. Since I'm running out of room, I'm just going to rewrite it. So I have 30 minus 2W less than or equal to 46. So now, to get the W by itself, I divide each piece by 2. So then half of 30 is 15, and half of 46 would give me 23. So that would have to be the range of the values for my width. So it can be as small as 15, or it can be as big as 23 feet. And I'll put feet here. So minimum 15 feet and maximum 23 feet. And I'm talking about the width. W for width. Alright, now let's look at this next word problem. It says Greg is thinking of a number n, and he wants his sister to guess the number. His first clue is that 3 less than 2 times the number is between 5 and 7. Write a compound inequality that shows a range of numbers that Greg might be thinking of. So again, it's specifically saying that we're going to be writing our compound inequality. So for the compound inequality, you want your minimum, less than or equal to some statement, and then your maximum. So I have my minimum value and my maximum value that I'm thinking about. So it wants to be, so Greg is thinking about a number n, and it says that his numbers are between 5 and 7. So if his numbers are between 5 and 7, so I specifically know what's going to be my minimum value. My minimum value is going to be 5. So now, thinking about my maximum value, well, the maximum number there is going to be 7. So now, let's think about what the middle part is going to be. Well, it says that it's 3 less than 2 times his number. So 3 less than 2 times, so less than, so that's subtract 3, and I'm going to reverse the order because it's less than, so I definitely know I'm going to be subtraction. And here, 2 times his number, well, I don't know his number, but he called it n. So now I'm going to have this as 2n minus 3. So now from here, to get n by itself, I'm going to add 3 to all sides. So that I have 8 less than or equal to 2n less than or equal to 10. So then from here, divide by 2 on each side. So 8 divided by 2 is 4, less than or equal to n, which is going to be less than or equal to 5. So he might be thinking about the numbers either 4 or 5. Okay. And that is the end of this section. If you guys have any questions, you can feel free to email me or the tutor or the Math Success Center. Thank you.